Okay, so I guess this is part 2 of using this circuit, using the Lasersaber circuit to charge a lithium iron phosphate battery. Now, this is actually kind of strange. Well, not too bad, I guess. I'm looking at the input now since I changed the meters. So it's on the 1 amp scale. It's reading 240, I guess, is the input, and the output is reading what would you say that would be? 150, I don't know, about 180 milliamps, I guess. So there's only a difference of 60 milliamps roughly from the input. That one's the input, that one's the output that's going to the battery. Now the voltage is lower. It would have to be a higher voltage if it's charging it, but that's what I'm reading on the across the battery. The battery's obviously loading it down some. And the supply battery is down to 12.4344, just kind of hovering there. Mainly because I'm not really drawing it really hard on the input right now. So now the waveform that I have coming across the full bridge rectifier is really weird. Like, this is coming right across the full wave bridge rectifier. It's on the positive, and I have the ground part on the negative. So it's reading right across the DC part of it. If I was to put it here, I guess that goes right to the negative of the battery. I don't know if it'll make much of a... No, it just fell off. But yeah, I don't know if you can see it, but it's what, 5 megahertz? I'm not quite sure why it's reading that. So I could take it off of that, put it, if I can get it on there. Jeez, oh, it's so hard to get on there. There it is. Okay, so what am I reading now? I'm still reading. Oh, it's 2.5 megahertz. It's a little different signal. Well, I could take it off of that and off of there. Pull it out of here somehow. Put it on the collector. And again on the ground. Let's see what I have here now. No, 1.27 megahertz. Like it's still way up there on megahertz. Different signal. Give another auto here. Yeah, still 2.23 megahertz. Yeah, it's really drawing high megahertz. Okay, so we're only at 11.9 on the battery. So I'll move the full wave bridge rectifier out of the way a little bit. Okay, I'm going to give it more current here. So let's see, that's 300. Now that's 400 milliamps, 400 milliamps. It's on the 1 amp scale. I'm drawing 300 milliamps on the input to the battery, and roughly 400 milliamps. Well, it's bouncing some there. Not sure why it's bouncing, but both of the needles are kind of bouncing a little bit. Okay, we still got more scale left, so we'll bring it up to 5. Okay, the input now to the circuit is 500. And the input to the battery is 380, I'd say. Something like that. It's still 2.1 megahertz, 1.9, 2.27. Yeah, it's bouncing all over the place. Well, it's charging this lithium iron phosphate battery, but it's not charging it super fast. Now I'm only at half an amp that I'm using. So I'm more limited to this meter here at 500. So we can bring that to pretty well 500 input to the battery, and that puts the input to the circuit at 700. The MOSFET, it's a little warm. Well, it's a little warm. It's not too bad. Get so I can put the coil on it to hold it down. I don't have it drilled or tapped or screwed down, so I just use the weight of the coil to hold it down on the aluminum plate. And well, it's a fairly good aluminum plate, so it's a good heat sink. But yeah, it's not charging super fast. It's charging, but it's not charging super fast. But like I say, if I'm only putting 700, well, not even quite 700 milliamps into the circuit, and it's less than 500 milliamps now. It's going into the circuit, and we're only up to 12.2 volts on this lithium iron phosphate battery. So I don't know, it's kinda strange. It has gone up from 10 volts to 12.2 volts, and my main battery here has gone from 12.62, I think, to 12.32. So this battery has only lost, what, I guess be 300, I guess it would be 300 volts, 300 millivolts, whereas the lithium iron phosphate battery has gained at least 2 volts. Because right now they're almost the same voltage. 12.32, 12.3. So they're almost the same voltage right now. Okay, I'm at 12 minutes. I got shut down.